All right, so here is our OpenShift console. Here we have 3 workers and 3 masters, one worker ending in H9, another SL and T8. If we head over to our flash array, we can see these 3 are mapped as well. And each one of these has 2 volumes. Note that because we're running the minimum amount of Portworx nodes, each one has a metadata device and a data device. So our data devices are actually 50 gigabytes in size, just so it makes for this autopilot demonstration to happen a little bit quicker. We can actually look at the volumes and dig into 50 gigabytes here, and you can see our PX cloud drives, which are 50 gigabytes, are right here. So if we head over to our Portworx node and run a pixie-cuddle status, we have an operational and healthy node here. And you can see that pool 0 and device 1 is a multipath device of 50 gigabytes in size, and that the metadata device is 32 gigabytes in size. So let's take a look first at the pool expand rule. So let's do a vi pool expand. Here we can see that the autopilot rule is named PX pool expand, and this rule here is currently set up for if the pool is less than 50% full in capacity. So we have 50 gigabyte pools on each one of our Portworx nodes. So that means if it's up to 25 gigabytes, then we will start to see this rule set in. The individual pools can't exceed 1 terabyte. And our action when this condition is met is to expand by adding a disk for our storage pools. So let's go ahead and create this. Let's go ahead and create this pool expand rule. And at this point, what we can do is also do an OC describe on autopilot rule on this particular autopilot rule. Here we can see that the 3 individual pools, so 1 pool per Portworx node, have transitioned from initializing to normal, basically saying that these pools are A-OK and their conditions are currently in a normal state. So now we have to create some load on the system. So let's take a look at our storage class, which has a replication level of 2, a Postgres volume of, let's say, we're going to say 50 gigabytes because that's the largest it can be. And we have our PG bench data, which is going to write 30 gigabytes of data. Now, let's go ahead and create that. Let's see, create autopilot PG in the PG1 namespace. All right, so now we've gone ahead and created that application, which is going to start adding to the load of the individual servers. So now when we head back to our console, we should see our PG bench and Postgres containers start to get set up. So this is Postgres 13 and PG bench, and it's writing to the PG bench DB data volume that's owned by Portworx. Now, if we head down to our storage tab here, look at our persistent volume claims, we can see our 50 gigabyte volume. And as it starts running, we should see this use percentage start to come back up. So let's head back to pods. Okay, so now we can see our pods are running. This should start to kick off the PG bench data. And now we can head over to our cube system namespace, and we'll dive into one of the Portworx terminals. And from here, we can run the pixie-cuddle utility. and look at our volume lists. So we can see our 50 gigabyte volume here with an HA level of 2 up and attached. And to get more information on that volume, we can inspect that volume. And here we can see that the consumer of that volume is PG Bench on this particular node. And it's looking at the pools of 0A00 and 1A86. So this is the replicas of this volume on these two pools. Now, if you remember our autopilot rule from earlier, let's head back and actually take a look at that. Let's do a describe. We can see that two of these pools, A00 and the 1A86, are in fact two of the pools that autopilot is monitoring that we can see here and here. So after a while, when this pool starts to fill up, these are the two pools that are going to be affected by how much space is being taken up. So we can actually see the amount of bytes written and how much bytes are used. So if we run this command again, we should start seeing our data start to rise. And so now we're going to head out and take a look at our persistent volume claims here in a second. But one thing I did want to show is as we're going through this, we do want to take a look at the service pool show command. As you can see, there's one 50 gigabyte volume as we talked about earlier, and this is the 0A00 pool, which is one of the ones that are starting to add data. So we'll take a look at this afterwards as it does indicate what's happening as it goes on. So let's head back over to our persistent volume claims for our PG1 namespace. And as this starts to be used, we should be able to see how much data is being used. And let's let it climb to about 25 gigabytes of data. And we should see something start to happen in our logs. What I'm going to do while this is happening is I'm going to set up a watch on the events. So let's do a watch on the events for the autopilot object and the name of PX pool expand. Here we can see those same transitions to normal, but as autopilot does its thing, we should see new events pop up here. So let's head back and wait for this data to be populated. Okay, so now we're getting close. Let's head back to check our specific volume here. So let's volume inspect. We have about 22 gigabytes of data. It's getting close to that 50% mark. So let's actually check in on the logs. So it remained in the normal state. And then we can see two pools get triggered here in the last minute or so. And what triggered means is that the condition has been met. So now what it's happening is the actions are pending and in progress. So the pending means that it's going to take action. It will do these pool rebalances and expansions one at a time to make sure that the pool is expanded and rebalanced before moving on to the next one. So at this point, we can see that the active actions in progress is for the 1A86 pool here. And what we can do now is actually take a look back at our cloud drives. And here we can see there's 4 cloud drives at 50 gigabytes now. So that means that there is a brand new cloud drive being provisioned automatically as an add disk expansion to that pool. So now what we can actually do is head back to our hosts and look at the OCP hosts, and we can see that our worker DPVSL has 3 LUNs now, 3 volumes. So what this means is that we can head back to our pods in Cube System namespace and take a look at the worker which is running that host. So I believe it was the VSL one. So it's not this guy here. Let's take a look at this. It's this one that is currently in maintenance mode. So that's what's happening here. So if we look at the logs here for Portworx, what we can actually see is the drive is being added to this node. So you can see the operation type is resize type disk add, and the storage rebalance is occurring. Now, what you should be able to see in here with this resize operation is that the operation is in progress, meaning the drive add is happening and the rebalance is running, and it has a certain amount of percentage left in order to complete. And so one thing you can probably do is head into this particular node, Portworx bin vixi cuttle, and we're going to do a service pool show. Here you can see that there's a second disk. Before we saw one 50 gigabyte disk. Now we see the operation resize is happening, and then we see that the operation is successful and the pool expansion to 100 gigabytes is in fact complete. So at this point, we should be able to run a PX-AutoPilot status and see that we have a full 200 gigabytes, whereas before we had 150, meaning that every pool had 50 gigabytes available. Now one pool has expanded to 100. So you see the capacity of node 1 is 50, node 2 is 50, and capacity of node 3 is 100. So if we head back to our original Portworx node that was running before, what we should be able to do, I believe it was this node. We'll find out. Portworx bin vixi cuttle service pool show. So here we see that the second node is now being resized. It gets taken into maintenance mode, so it is currently offline, but it is in progress, and it shows the amount left. So you can get this information from the service pool show command or from within the Portworx logs themselves. And at this point, if we went back over to our flash array, we see now 2 nodes in the OpenShift cluster have 3 volumes associated with them. So what we've effectively seen is our autopilot rule, which should still be showing what's happening, is that the events are triggered based on a rule. In this case, it says when the pool gets 50% full to trigger this condition and take an action of increasing it by adding a disk. And in this case, we had 1 go into progress and then 1 actions taken. And then the second one starts to be in progress and will be actions taken. So this is how the Portworx storage pool becomes expanded using PX-AutoPilot for the underlying storage backend using the cloud drives technology from Portworx. So Portworx can not only expand your PVCs, but expand your underlying storage pool and rebalance the replicas across those pools once it's complete. So let's see how close we are to being done here. We have about 59% left. We're going to let this complete and be right back. All right, let's check in back to our storage pool, and now we have a complete operation for the second pool, and now our node is back online. So if we run a PX-AutoPilot status on the entire cluster once more, we now see we have 250 gigabytes available, where 2 of our Portworx nodes are both increased to 100 gigabytes in total storage pool size. This happened automatically by letting Portworx use autopilot rules to watch what's going on in the usage of the individual pools and take action by adding a disk, automatically adding more storage space for your overall OpenShift application consumption. And so this lets OpenShift users and OpenShift applications to provision just what they need at first, and as they grow and as they scale, let PX-AutoPilot scale the backend storage for you. And that's all we had for you today. Until next time, take care.